Hello everyone. Today let us continue class 6 mathematics playing with numbers exercise 3.5. Already we have solved 8th problem. Now this is 9th one. Let us move on to the 9th. In which of the following expressions prime factorization has been done? Here there are 4 expressions which are given. You should check whether the factors of the given number are prime, because if the given factors are prime, then the particular expression is said to be prime factorization. Now first A1. Let me move on to the A, that is 24. 2, 3 and 4. 3 factors are given for 24. 2 3s are 6, 6 4s are 24. But as you can see here, 2 and 3 are prime numbers, but 4 is not a prime. So we can say that 24 is equal to 2 into 3 into 4. In this expression, prime factorization is not done. Therefore, the given expression prime factorization has not done because 4 is not a prime. 4 is not a prime number. 4 is a composite number. So we can say that the given expression doesn't hold any prime factorization. I do repeat it. 24 is the given number and the factors of 24 are 2, 3 and 4. According to the given factors, if you say 2 and 3 are prime, 4 is not a prime. Therefore, you can say that in the given expression, prime factorization has not done because 4 is not a prime number. Now, let us move on to the next one, that is 56. 7 into 2 into 2 into 2. 7 2s are 14, 14 2s are 28, 28 2s are 56. Here, this is purely, these factors are prime factors because those are prime numbers. Therefore, in the given expression, prime factorization has been done. Has been done because all factors are prime. All factors are prime numbers. All factors are prime numbers. I do repeat this. 56 is equal to 7 into 2 into 2 into 2. As you can see here, 7 is a prime number. 2 into 2 into 2, all 2's are prime. Therefore, in the given expression, prime factorization has been done. 56 is equal to 7 into 2 into 2 into 2. Because all factors are prime numbers. Let me move on to the next number, that is 70. 70, we can say that 2 into 5 into 7. 2 5s are 10, 10 7s are 70. As you can see, all the three numbers are prime. Therefore, in the given expression, prime factorization has been done because all factors are prime numbers. All factors are prime numbers. Now let me move on to the next problem, that is 54. 54 is equal to 2 into 3 into 9. Here you can see 2 3s are 6, 6 9s are 54. But 2 and 3 are prime, 9 is not a prime. Therefore, in the given expression, prime factorization has not done because 1 is not a prime number, because 9 is not a prime number. 9 is not a prime factorization. Let us move on to the 10th problem. Determine if 25,110 is divisible by 45. Hint is given here. As you can see, 5 and 9 are co-prime numbers. Test the divisibility of the number by 5 and 9. 5 and 9 are said to be co-prime because both have common factor only as 1. Rest all factors of 5 and 9 are uncommon. So those are co-prime numbers. First let us move on to the divisibility of 25,110 with 9. Then we will check out with 5 whether it is divisible with 9 or not. 9 2s are 18. As you can see, this is a one digit number, and here we have to consider two numbers because the first number is smaller than 9. So 9 2s are 18. If you subtract here, this is 15 minus 8 is 7. This is 1 minus 1 is 0. Now bring down 1. 9 7s are 63. 9 8s are 72. 72 will be more, so we can't take 72. Greater than 71, let us choose 63. If you choose 63 here, this will become 11 and this is 6, this is 8 and this is 0. Now bring this 1 down. This is 81. 9 9s are 81. As you can see here, the 0 we cannot divide it, put in a quotient. Now if you write the prime factorization table, 2 1 1 0 9 2790 is the 25,100. That means 9 divides 25,110 completely. Then therefore 25,110 is divisible by 9. Is divisible by 9. Now let me move on to the next part, that is B. Check the same number with 5. 25,110. First let me show the division. 25,110 with 5. 5 5s are 25. 25 minus 25 is 0. Bring 1 down. You cannot divide 1. Put a 0. Take one more number, that is 1. 5 2s are 10. 11 minus 10 is 1. And this is 1 minus 1 is 0. 1 minus 0 is 1. 1 minus 1 is 0. Bring this 0 down. 5 2s are 10. So here also same thing. This number completely divides the number and the quotient is 5 into 5,022. 5 divides this number, that is 25,110 completely. As you can see, remainder is 0. In both the cases, if remainder is 0, here also same and here also both the remainders are 0, then we can say that both the numbers divide 25,110 completely. Therefore, 25,110 is also divisible by, also here you can say, therefore 25,110 is divisible by 5. Is divisible by 5. So 25,110 is also divisible by 45 because 5 and 9 are factors of 45. Factors of 45. 5 9s are 45 or 9 5s are 45. Both are factors of 45. So if the factors divide the number separately, then the product of the factors, that is 5 into 9 is 45, will also divide the given number. I do repeat once. As you can see, 25,110 is divisible by 9, and here also by observing this division, 25,110 is also divisible by 5. Therefore we can say that 25,110 is also divisible by 45. Reason is because 5 and 9 are factors of 45. If factors divide the given number, their product or their multiple will also divide the given number. Now let us move on to 11th problem. 18 is divisible by both 2 and 3. It is also divisible by 5, 2 into 3, 6. That means the product of 2 into 3. Similarly, a number is divisible by both 4 and 6. Can we say that the number must also be divisible by 4 into 6? 24. If not, give an example to justify your answer. As you can see here, 2 and 3 both and 6 are all the 3 are factors of 18. And here 4 and 6 are factors of 24. We should choose a number where 4 and 6 should be factors of that number, and whether it is divisible by 24 or not, we should check. I suggest 12. Let me check with 12. 12 is a factor, 12 is a multiple of 4. 4 3s are 12, and also 6. 4 into 3 is equal to 12. 6 into 2 is equal to 12. That means both are the factors of 12. But 12 is not divisible by 24. 12 is not divisible by 24. But 12 is not divisible by 24 because 12 is smaller than 24. 24 cannot divide 12. Even though its factors 4 and 6 divides 24, 12 is not divisible by 24 because this is greater. But here in this case 18 is greater than 6. 6 can divide 18, but not 18 divides 6. Here same thing, because the number which we have chosen is 12 is smaller than 24. It is not divisible by 24. Let me move on to the next problem, that is 12th one. I am the smallest number having 4 different prime factors. Can you find me? Let the number be x. Let the smallest number be x. Why we are taking x? Because it is an unknown number. Now, having 4 different prime factors, that is x is equal to 4 different prime factors we should choose. That is, let me move on with smallest prime number 2 into the next prime number 3 into 5 into 7, because they have given 4 different prime factors. All the numbers which we are writing here are the prime numbers, and also if you multiply and write the product, that number will be the smallest number, and these are the factors of that number which will be formed. Now 2 into 3 is 6 into 5 into 7. 6 5s are 30 into 7s are 210. So therefore x is equal to 210. 210 is the smallest number having 4 different prime factors. I do repeat the solution once. Let the smallest number be x because it is an unknown number. X is equal to, consider 4 different prime factors. You can choose any of the prime factor here, but all the factors should be different. I am choosing the smallest prime number 2, then next 3, 5 and 7. 2 into 3 into 5 into 7, and this is the smallest number. Because why we are choosing smallest prime factor here? Because we should get the smallest number which has all the 4 factors different. It should not repeat, no factor should repeat here. So 2 into 3 is 6 into 5 into 7. 6 5 is 30 into 7 is 210. Therefore x is equal to 210. Therefore 210 is the smallest number with different 4 different prime factors. With 4 different prime factors. So, as you can see here, 210 is the smallest number with 4 different prime factors. So, this was the last problem from the exercise. We'll stop here, and in our next video we'll move on to the next exercise.